Tiana, so thanks again for submitting us this question. Um, there's a few things going on, but I think more important to the actual questions here um, is your understanding of the concept overall, because each one of these three questions is essentially a repeat of the same concepts, just in a slightly different context. So the main thing here, right, is okay, how do you construct and use dominance matrices? And how do you use different orders of matrices and why? Like, why would that change the ranking? And then we'll put it all together and I'll show you how I might attack question three. Hope that sounds all right. Okay, so this is just the question one matrix they've used here, and this is the dominance matrix. And you can imagine that, and I'm guessing you're kind of across the very basics in terms of a dominance matrix has all of the participants or teams or whatever it is here. In this example, it's students. And you look at, okay, did individual A, team A, whatever, outperform team B? And outperform is subjective. It's like, okay, well, not subjective. It depends on the context. So here it's, did they have a higher subject score? In the later problem, it's, did they win the game, right? So if A outperformed B, they get a 1 there. If A doesn't outperform C, in terms of C outperforms A gets a 0 in its row, and C would get a 1 versus A in its column. In C's row and A's column. So that's the principle there. And what the point of this is to figure out a ranking. And how that happens is because all of player A or student A's wins are in their own row, if you tally up the row, all the rows, so 2, 3, 3, 3, 1, and 2, this now gives you the strength of each player based on just pure win-loss. So in this scenario, it would have, okay, student B, C, and D would be the top. And then equal second would be A and F. And third would be E. The issue, right? So this is just using D, the dominance matrix, which is in blue, right? So I've used the dominance matrix and I've summed all of the rows to give dominance scores. But you'd notice here the issue is that there are ties. So we actually don't have a definitive ranking here. We could not tell you who is the Ducks out of these students. And look, it's arguable whether doing second and third order dominance is actually the best way to differentiate rankings. But what is clear is that it is a good method that's mathematically sound and that you need to use in this syllabus. So whether or not it's the best method is arguable, right? Like there might be other things that would better separate out who's the top performer depending on the context. So might be different in a soccer tournament versus finding out who the Ducks is, right? But because it specifically wants us to use dominance matrices, we can kind of ignore what the context is and just treat the matrix as a dominance matrix without worrying about it. So how we then separate something like this is through using second order or third order dominance. All that tells us is we can square that matrix or we can cube that matrix, and that will adjust the rankings. Why? Is because it accounts for indirect dominance. Or the theory that if you beat Team A, so Team A beats Team B, and Team B beats Team C, this doesn't have any effect on first order dominance in terms of the relationship between A and C. But in second and third order dominance, what starts to happen is you get this kind of degrees of removal. In terms of, in second order dominance, this would be considered as A is dominant over C. At least for this part of the matrix. Like A might have lost to C, but they will get credit in their row with respect to team C because of the fact that they beat B and B beat C. So it's that kind of concept of, okay, looking at, did they beat good opponent? Like if we just take a sporting context, I think that's the easiest to look at. Did the team beat other good teams, or did they just beat teams that didn't have any other victories? And so that's what indirect dominance looks at, and it can be a more precise way to separate the rankings. What can also be the case, and I'm unsure, to be honest, what the context behind this actual chapter is of your textbook, but sometimes when we do this, we want to add in like certain scalars. So like if we do the second order ranking, we might want to halve it. On the third order, you often want to put it to a third, because we don't want to give as much weighting to this kind of dominance as we do to this kind of just pure dominance, right? So that's why we kind of scale it down a little bit. The more degrees removed it is from the actual like opponent versus opponent matchup, you can scale it down a little bit. I'm not going to touch on this right now, just because I don't know if that's what you're expected to do with these questions. And also because I don't think that's the necessarily difficult part in terms of understanding here. Like you can scale the matrices down if you want, and it's just multiplying by a scalar. Like it's not actually adding much complexity to the question. All right, so what I want to go through is just like a whole question, is question 3, the problem solving one, because it takes everything we know and requires us to apply it here. So the end goal is to rank the teams from first to fifth and explain the method. So we've got a series of games here, and we need to characterize them as either wins, losses, or draws to turn it into a matrix. The draws are interesting, so we can say let a win be 1 point and draw be 0.5 points. That's one way to do it that works. And so when we create a matrix, if we just go through and list like, okay, cats win, eagles win, draw, we could create a matrix that looks something like this. Okay, so I've gone in and I've created the first order dominance matrix here. Just based on the results of all the games, I've awarded a draw 0.5 point and a win 1 point. And so what we can do here is just find our initial ranking by adding up the columns. So 0, 1, 2, 3, 2, 2, and 3. So clearly here we don't have ranking separation yet. So what we might go and do then is, okay, let's find our second order dominance. And so I'll go and do that now. Okay, so I've then gone ahead and done the D squared matrix. And you can just use your calculator for this. So if you store the initial D matrix, and then you just square it in your calculator, like square the actual letter that you assign it, it should create D squared. What I've gone ahead and done then, just for clarity's sake, and give you an easy strategy. If you want to just find the rankings directly from the matrix, all you need to do is multiply by a matrix column of ones that matches the size of the actual matrix. And so for D2, this is what I got for the matrix. Now we could add these two together and apply some scalar multiple to it. But I want you to just notice that we're trying to separate these two as well as these two. For 3 and 4, Yeah, we got some separation there. So that's good. But we actually haven't separated the bears and the cats yet. So we're either going to need to go to the third order or apply some other type of consideration to separate these teams. I'll do the third order now, and I will see what ranking change that um, creates for all our teams. All right, so as the outcome of d cubed and then multiplying it by our column of ones, this is the resulting ranking matrix I got. And unfortunately, you'll notice here that, look, our highlighted teams still haven't been separated. And like you could go through the whole thing of, yeah, let's actually like calculate like d plus half d squared plus a third d cubed. But it's not going to matter. These are all the same, and we can see that. And so, like, we've got a ranking already. So from this, like, we've already got a ranking for all our other teams. So we know that bears and cats, I believe, are tied for first. And then this top team, so this team in third, has clearly separated itself. So the stars are then next. They've separated themselves from the eagles through our second and third order. So the second and third order will be valuable for that. And no matter what kind of scale we apply, it'll be a little bit more than the eagles because it's above in both metrics. And then last is the dragons, clearly. So how can we reconcile this? And again, like I'm not adding it together or worrying about scalars because the question just asks us to rank them. It doesn't ask us to like quantify what their score would be or anything like that. So this is what we're looking at the moment, and it's annoying. So we have to think, and this is why it's a problem-solving question. How could we separate first and second? Well, what jumps out to mind for me is you can go back to the actual schedule and consider as a tiebreaker the actual point differentials between the teams. And it doesn't really matter for the other teams. We're just looking at games that involve the cats and the bears. 1, 2. They're just +2. So they're +0, +0, +1, +1. So they're +2. Whereas the bears here were +1, +1, 0, and 0. So they're also +2. Okay, so that's probably where you would go to first. But in actual fact, that doesn't separate the rankings here. So potentially what I can think of as the tiebreak then. If all of our 3 orders of dominance don't separate these two teams, and their actual goal differential doesn't, which is probably the better metric of like kind of for and against ranking. What we could also look at is maybe total goals as a tiebreak. And again, here, this goes beyond, this is why it's problem solving, right? It goes beyond the order of just looking at, okay, we've got second, third order, they don't actually separate them. So how can we use other kind of metrics here? And again, our scalars are not going to separate these because there's no difference in the rankings in either model. So if we look on total goals, which maybe could be like a tiebreak system in the competition, we can see that the cats have 2 plus 3 plus 0 plus 1, and the bears have 1 plus 1 plus 0 plus 2. So overall, the cats scored 6 goals, and the bears scored only 4. So potentially this is a way where you can just, and for explaining our method, we tried using all 3 dominance orders. We tried using point differential. So potentially the lowest common denominator that we could separate them on was total goals. And so our justification on the ranking there, therefore, could be that we have cats over bears because of their total goals score. So I'd suggest that that might be your ranking there, but definitely a difficult problem. Overall, though, look, the broad takeaways are that, okay, understanding what is the point of second order and what is the point of third order dominance, why do you usually scale them down? why does scaling them down actually not impact the rankings in this context? And I guess how do you interpret and draw up dominant matrices? And yeah, a part of it as well is just making sure that your like calculator processes are right in terms of like it's very easy to just skip one number or stuff up the multiplication slightly or even the order of it. So that's something to be careful of. But I think, yeah, number 3 is an interesting, and like 1 and 2 for the same kind of thing. It's just 1 and 2, you can separate it at the third order. And so that's to illustrate that. But number 3, I just wanted to go through because it targets, okay, you go through all 3 orders and it's still not separated. What might you do in kind of an exam scenario? So that's something you can look at. But yeah, I hope that's helpful, Tiana. Thank you again for submitting this one. If you got any further questions on that, or there's anything you would like to clear up, just leave a comment. Can easily get back to you there. And yeah, if you enjoyed, I really appreciate your support. Feel free to like or share this video with anyone that it could also help. But yeah, thanks very much, Tiana. Appreciate it.